Okay. Yeah, I know. I was just checking to make sure the mic was there. Okay. So let's do, I'm going to label this trig number 4, okay? And then you can see what the solution is. You can go back up and see it, okay? So a tunnel goes through a mountain. From the two ends of the tunnel, the angles of elevation to the peak are 37 degrees and 49 degrees. Find the length of the tunnel if the peak is 2,750 meters above the tunnel. Okay, so let's draw our picture. Okay.
Is that in the textbook?
I actually don't know if it's in the textbook. Again, I didn't write this at review.
Oh, that question from the review.
This is what do you mean?
The question we're doing right now is on
At the exam review, number 4. Yeah. Okay. I figure this kind of does a dual purpose. Like we're reviewing trig for the test today, and then also for the exam. Okay. So here's the scoop. Here's the peak of the mountain, right? Everybody agrees? Okay. It says that the peak of the mountain is 2,750 meters above the tunnel. Let's say the tunnel's negligible in terms of relative to the actual mountain, right? Tunnel's running through here, something like this. Okay. It says the angle of elevation to the peak is 37 degrees on one side and 49 on the other. What is angle of elevation? We have a horizontal. In this case, it's the ground. And I measure up 39 degrees and I measure up 49. Okay, so those are the two angles that go in here. Okay, any issues? What have I drawn in this question that makes it a nice question? What have I drawn in this question that makes it a nice question, relatively speaking? Are we going to use cosine law as my question? No. Am I going to use sine law? No, because what do I see in this question?
Right angle.
I see a right angle. Okay. Oops.
Could you do cosine law or like sine law?
Yeah, but I mean, again, like you're gonna run out of time, and we're gonna take your test away, and you're gonna have 4 questions blank because you chose not to use the most efficient method. I don't care if you sit there. If I say factor, and you want to sit there and type every one of those questions into the quadratic equation, and then still think you're gonna finish the rest of the test, good luck. You're gonna get 20% on the exam because that's how long it's going to take you. I show you all these things because they're more efficient methods to get the answers.
I mean, there's still going to be questions where you're going to need to use the quadratic.
Absolutely, but you're going to have to decide, like, that's going to be built into the allocated time of the exam. You can't sit there and just use the method that works all the time just because you know it works all the time. You have to use the other tools that we've given you. Right? So, what are we going to do here? I see 2 triangles. I see 2 triangles because I broke it in, not necessarily half, but I've broken into 2 pieces with the height of the mountain. So you could, in theory, say, here's A, B, C, and then you could call this one D. Okay. The nice thing about labeling triangles this way is a little bit less like, I don't know. You can, we know what each of the line segments are basically, right? It gets a little bit easier from an organizational standpoint. Okay. So if I want to solve for, like, remember the question is, the question's asking us for what? How long is the tunnel? Right? How long is the tunnel from here to here? That's what it's asking us. So I don't necessarily can't do that in one step. But what I can do is find two numbers. I can find one here, and I can find one here. If I add them together, then I get the total length. We've kind of already done this. You guys remember the question where we were like standing in a building and we looked up to the top and looked down to the bottom and we found X and Y, the two pieces, and we found the total height of the building? This is the same question. We're just going to turn it on its side now. Right? Any questions so far? Okay, we'll do this one and then you guys can go for break. Okay? And then we'll do trig all of period 2. Okay, and I'll figure out when the pictures are going to be. Okay, let's solve for x. So let's ignore. You guys, I think, have a pretty good grasp on. Like, if we just ignore this half of the triangle for a sec, you know how to do this. Solve for x using Sohcahtoa. I'm using Sohcahtoa because I have a 90 degree in there. Right? So which one am I going to use? I know what the I'm standing here and I look across and this is opposite. Right? I know this is opposite. I know that side length x is going to be adjacent, and I know the angle. So what am I going to use? Tangent, because of opposite and adjacent. So I'm just going to go tan of 49 is equal to opposite over adjacent. Opposite over adjacent. The opposite side length is 2,750 over x. Solve for x. This is kind of the stage where we said we can do one of two things. You can cross multiply, or you can kind of like multiply both sides by x and then divide both sides by tan 49. Would you guys prefer, if, for the purposes of this video, we found what, or this is question, do you want a number for tan 49 right out of the gate? That's fine. Do we have a decimal for tan 49? 1.1503, Retta? Okay. That's equal to 2,750 over x. Okay, all I did was find this number. I went to 49 on the trig table, and I read over to the tangent column, and I got that number. Or something very close to it. Might not be exact. Okay? All you're doing is solving for x now. Multiply both sides by x. This is a hard one, because, right? And then so you get your next line, the x's cancel, right? And so you get x multiplied by 1.1503 is equal to 2,750. Divide both sides by 1.1503. You have x by itself. These cancel. X is equal to what's x equal to? 2,700 meters. Okay, is that the length of the tunnel? No, it's only one piece of it. I gotta go back to the other side now and do the same calculation and find y. Right, so let's just erase this stuff so it doesn't get too ugly and too much to look at. Okay, we're just gonna restart the question now, except I'm on the right half of the picture. I'm standing at 37 degrees. I look across and I see opposite. Beside me is side length y. That's going to say adjacent. That's what we're looking for. Which trig ratio are we using? Tangent again, because it's opposite and adjacent. So let's go tan of 37 is equal to opposite over adjacent. So we get 2,750 over y. Solve for y. Does anybody have the number for tan 37?
Mr. Mackay, 2750 divided by 1.15 is 2,390.
That, Sarah?
0.68.
You better check that, Retta. Check it. Okay.
We're going right like the 0.3 or something.
Okay. Okay. Now, do we have a number for tan 37? 5.3? That's let's call it 5.4. Is that whatever we got? Before we get too far into this? 7.53. That's good. Okay. That's equal to 2,750 over y. We're going to do the same solving tactic that we did earlier. Just going to bring the y up and then bring the decimal value down. The exact same thing as over here. So what we're going to get is y equals, and I don't care if you guys don't show this work anymore, like we're at the stage where hopefully you can just do this. Oh, careful, buddy. Careful, careful. Guys, be careful with the number. Should be 0.7535. Just check that. I thought that was a little bit. As soon as I put it underneath, I knew I was going to get this gigantic number. Okay, just be careful with where you put the decimal places. It was the right number, we just had the decimal place in the wrong spot, I think. Okay, so we have that answer? 2,750 divided by 0.7535. Okay. Is that total length of the tunnel? Okay, we got to add them together, right? So total length equals x plus y. Do we have an answer? Oh, okay. Okay, you guys could write a therefore statement too. Therefore, the tunnel is 6,040.34 meters. Okay.